going to be talking about real numbers, and we're going to be talking about irrational and rational numbers. I want to start with a review with our definitions. Classifying, comparing, and ordering real numbers. Here are definitions. Integers, the set of whole numbers and their opposites. Rational numbers, any number that can be written as a fraction, positive or negative. Irrational numbers, any number that cannot be written as a fraction, a non-terminating and non-repeating decimal. And real numbers, irrational or irrational numbers. For today, we're going to be focusing more on comparing these and ordering these. For example, ordering these from smallest to largest. Before we begin ordering these, let's go ahead and just do some real talk about some real numbers. Real numbers break off to either rational or irrational numbers. Irrational numbers can be square roots that are not perfect square roots. For example, here's that pi symbol, 3.14. That is not going to give us a perfect square root. The square root of 2? No perfect square root for 2, and no perfect square root for 3. So that leaves us the rational numbers. Rational numbers can be decimals. Rational numbers can be fractions. Rational numbers can be integers, which are whole numbers, and natural numbers. And natural numbers are perfect squares. Now, to compare and place real numbers in order, we can make approximations or guesses of the values of the irrational numbers as decimals. So our goal is to get as close as we possibly can to that perfect square root. For example, we can use perfect square roots to estimate. For example, here's 4. Square root of 4 was 2. Square root of 9, which is 3. 3 times 3 will give us 9. 16, square root of 16 is 4. 4 times 4 is 16. So it's the number times itself. Okay, and this is what we would call perfect squares. Now, you can use a perfect square to help you figure out those that aren't perfect. I'm going to say that again. You can use perfect squares to figure out those that aren't perfect. I told you that these are perfect squares. So let's take a look at this is a problem right here. And these are similar to the ones that you're going to be working after the video. Square root of 12 plus 6. Pretend that that is not there, but you need to know greater than, less than, or equal to. 12 plus the square root of 6. So, we've got the square root of 12. There is no perfect square for 12. So we've got to think of what could it fall between? What could 12 fall between? So we know that the square root of 9 is 3. If we go back over here, we see the square root of 9 is 3. And if we move here, we can see the square root of 16 is 4. So we know that 12 is going to fall right in here between 9 and 16. So we need to meet it halfway. So it must be between the 3 and the 4. So it's got to be between 3 and 4. So let's play it safe and just say 3.5. So we're going to say, okay, the square root of 12 is 3.5. And they want us to add 6 to it. So we take 3.5 and add 6 to it. Be careful to line these up exactly right, because that 6 is a whole number. So that's where we're going to get 9.5. Make sure you line that up correctly, or it's going to throw you off. Now, we're not done yet. Now we've got 12 plus the square root of 6. So we've got to find a perfect square of 6. I don't think there's a perfect square of 6, but we can get close. So let's see how close we can get. We see that the square root, so the 6 must be between 2 and 3. So when we go here, we see the square root of 4 is 2. The square root of 9 is 3. So 6 is going to fall anywhere between 4 and 9. So 6 has to be here. So the square root has to be between 2 and 3. So let's just say 2.5. So that's going to, then we're going to say 12 plus 2.5. And we need to make sure we line that up right. So we've got 12. And then we've got our 2 here because 2 is a whole number. Did I do that correctly?
Yes. Yes, ma'am.
So that's going to give us 3.7. So, which...
Miss Heath?
Yes.
I'm pretty sure you did that wrong.
Okay, I like that. I do these types of things to see who is paying attention. I love it. Now tell me what I did wrong.
The 12 is supposed to be a whole number.
Thank you. All right, so the 12 is a whole number, so what is this?
2.5.
So is this added correctly?
No, ma'am.
So what should the correct answer be?
14.5.
14.5. Absolutely. Awesome. Now what we need to do is to determine is this right here. So this is 14.5 and this one is 9.5. Which one is greater?
12 plus square root of 6.
The square root of 6. 12 plus the square root of 6. This is why I made this greater than. Good catch. I like the way you're not falling for those good old tricks that I try to put on you sometimes. Next, this can help us list a mix of rational and irrational numbers from least to greatest. So now what we're going to do, we're going to place all of these in order from the smallest to the largest. I have a square root of 12, 7, pi plus 2, and the square root of 25. These are my perfect squares. And make sure that you learn these. I can give everybody a copy of these for them to use. These are perfect squares. So let's move over here to my third poster. These are the problems that we're working, and we're going to put these in order from least to the greatest. So we put these in orders from least to greatest. There's that 12. So we got to figure out where would 12 be because we know there's no perfect square for 12. So we know that it's got to fall between 9 and 16. When I say it falls between 9 and 16, if you back up with me just a little bit over here, here is 9, square root of 9. Here's the square root of 16, which is 4. So if it falls, so 12 has to lie right there in between. So I'm going to come up with a middle ground, which would give me 3.5. So I'm moving back over here. So that's why I said I'm going to say 12 would be closer to 3.5. 7 is a whole number, so I'll keep that. Then I have 3.14 plus 2. And 3.14 is going to give me what, class? Plus 2.
5.14.
5.14. Very good. Because 2 is a whole number. Then I'm going to have 5 here. So now I've got to figure out how to order these from least to greatest. My smallest number is 12. It is the smallest. Then I'm going to do the square root of 25 because it is 5. Then I have my pi plus 2, which yielded us 5.14. And then I worked my way up to 7. So why is 12 the smallest, though, and 7 is here, class? If this is, are you saying that this is the smallest? Or is it 12 that I'm looking at, or the answer to 12?
The square root.
It's the square root of 12, which would be 3.5. So we're looking for the answer. So that's why when I put it on the number line, it helps you to see it better. So the square root of 12 would be 3.5. I marked it there. Square root of 25 is 5. It would go next. So we're going from 3, small, up to 5. Then we're getting larger. We said that would be 5.14. There that is right there. And then last was the 7. Number line. Number lines really help you see it clearly. And let's do one or two more. Let's take a look at this. 3.14 squared. That means I'm going to double that. So 3.14 squared would be 3.14 times 3.14. You can set this up however you want to do it. But your answer is going to be 9.86 once you do the math. So that's going to be 9.86. We're going to keep 9 as is. Then right here, the square root of 74. Oh my goodness, 74. I don't know what to do with that. Well, I don't know the square root of 74, so I've got to think about what would it lie between. So I'm thinking, I know, I got to think about what do I already know. I know the square root of 64 is 8. I also know the square root of 81 is 9. So I know that the square root of 74 is going to fall somewhere between these. 64, 81, 74 has got to be in here in the middle. So to play it safe, I'm going to go with 8.6. Because 8.6 should fit anywhere between 8 and 9. So I'm going to take 8.6 and double that or multiply it by 8.6. And when I do the multiplication here, it's going, and I was right because it gives 73.96, which is close to 74. So I got really close to 74. So I'm going to say that the square root is 8.6. Any questions? So the last one is 89. So the square root of 89, I know I can get up to 81. Square root of 81 is 9. And then what about 100? Square root of 100 is 10. So let's try that to see what would fall between. So I'm going to say, let's take a guess, 9.4. 9.4 times 9.4 would be 88.36. That's pretty close to 89. So I'm going to say the square root of 89 is 9.4. Now, plug it in on the number line and get them in order. Here we go. So I say my smallest number is 74 because the square root of 74 we said was 88.6. So I hope you can see. If you need to zoom in, you can zoom in. But here's 8.5. So we're going to put the 74 there. So then 9 is a whole number. Look how we're going from 8.5 to 9. Then the square root of 89, we said the square root of 89 was 9.4, so we're getting smaller, and now we're getting bigger and bigger, and our largest one is pi squared, which is what? Pi squared, which was what?
9.86.
9.86. So that's how we did it. I hope this video helped. I hope you enjoyed real numbers, irrational numbers, and classifying those. Look forward to seeing you tomorrow. Have a good one.